It has got a spring-loaded safety mechanism, an entry point into the abdominal wall, the shaft, and this is the entry point for the carbon dioxide. There is a ball in order to prevent sudden gush of carbon dioxide or blood from the abdominal cavity while introduction. Prior to introduction, the safety mechanism, spring-loaded safety mechanism, needs to be thoroughly checked by pressing it against a firm structure. This is how we check for the safety mechanism. Secondly, we need to check the patency of the Veery's needle. To check the patency, we can inject saline into the Veery's needle and look for the patency. While introduction, the Veery's needle needs to be held like a dart and should be pointing caudally, so that an imaginary line drawn towards the anus is the direction of the introduction of Veery's needle. Because of the sacral curve, the pelvis is a roomy cavity and the chance of bowel injury are minimum. This is a 10 mm port. It has got an outer cannula and a trocar inside. The port has various features. For example, the thread, which prevents its sudden coming out of the abdominal cavity. It has got a side port for carbon dioxide. While introduction, this needs to be put in an off position, and after connecting it to the carbon dioxide, this needs to be put to an on position. It also has a flap mechanism in order to prevent any carbon dioxide leaking back from the peritoneal cavity. This is how the flap mechanism works. Then it has a rubber washer which forms a seal around any instrument which is introduced into the port. While introduction, the head needs to be resting against the theater muscles and the index finger is held close to the anterior end in order to prevent its sudden entry into the abdomen and thus injuring the visceral This needs to be introduced with a screwing movement inside the abdomen. This is in contrast to a disposable port wherein the screwing movements are not important by introduction because of the presence of a cutting mechanism right in the introducing end of the cannula of the port. Now this disposable port before introduction needs to be charged like this, and once it has been put into the abdominal cavity, it automatically switches into an off position where even after pressure this will not injure any viscera. It has got a trocar and a shaft, and it has got a side port for entry of carbon dioxide. Now, similar ports are also available in 5 mm sizes, the non-disposable and the disposable ones. Is the Maryland forceps. It is one of the most commonly and widely used instruments in laparoscopic surgery. It's got a handle, an attachment for connection of cautery, the rotating mechanism, the shaft, and the claws, the jaws. It is one of the most commonly used instruments in laparoscopy and is basically a modification of the artery forceps which is used in open surgery. It can be used for fine dissection, for holding the bleeding artery or the bleeder, or for holding the ducts, and some surgeons are also using it for holding the needle. The grasper has a handle, a rotating mechanism, the shaft and the jaws, and a very unique mechanism which is the locking mechanism. See, when we lock, now these handles cannot be opened themselves, so that the surgeon does not have to exert himself to hold these handles together. And for opening it, we need to press it for a second time. Now this grasper is used for holding the Hartmann's pouch, and together by holding the grasper in the left hand and the Maryland forceps in the right hand, dissection in the callus triangle can be carried out smoothly. A slight modification of this grasper, especially of the jaws. The jaws are toothed, and this has got a stronger grasp so that this can be used for holding the fundus, and depending on the skill and the preference of the surgeon, this can also be used for holding the Hartmann's pouch of the hook, and is used for removing the gallbladder from the gallbladder bed. This is a shaft which is insulated, whereas as you can see in this particular instrument, the insulation has been damaged from this portion. So before using, the surgeon needs to check the insulation. If it is damaged, this can burn the liver or the intestine and should never be used. This is the point for attachment of electric artery. It starts the irrigation into the irrigation device, and whereas when you turn it towards the other side, it starts sucking from this end, and while in the neutral position, both the ends are closed. These are the laparoscopic aspiration needles, and they are available in various sizes. This is a smaller size and a larger size. These are used for aspirating pus from gallbladder, empyema gallbladder, any liver abscess, or any other pockets of pus within the abdomen. As you can see, this is the sharp end. This can be put per-abdominally into the gallbladder or any of the pus cavities for aspiration. This is the long shaft, and this is the end where suction can be applied. Similarly, it's available in a bigger size, where the special attachment to load or charge the needle. As you can see, while I press, the needle charges, and while I release it, the needle comes back, and this is the area from where suction can be applied. The jaws, laparoscopic biopsy forceps, and as you can see, this is the place from where you can take the biopsy, and this has got a long shaft. This is the rotating knob. This is the place where you can attach the electric artery, and the handle has a ratchet mechanism, so that once you close it, it is a self-locking mechanism, and for releasing, this can be just released. Clip applicator. It has got a handle which has a self-opening mechanism, so that once the pressure is removed, it automatically springs back to the open position. It's got a rotating mechanism, the shaft, and the jaws. Now, for engaging the clip, this needs to be held in a dart-like position and vertically to hold the clips, and as you can see itself, it will engage the clip. Now, while application of the clip, the structure needs to be visualized carefully, and for clipping, the procedure involves partial closure of the clip applicator so that the ends of the clip come together, and after this it can be adjusted to the suitable position and finally closed completely to have a firm grasp of the structure. These clips are available in various sizes. For example, this is the medium large and the large sizes. They are also available in small and medium size besides this. This extractor, it's got a handle, the rotating mechanism, the shaft, and the jaws which should hold the gallbladder. For removing the gallbladder from the dural cavity, this needs to be opened, the gallbladder caught hold of from the neck with these jaws, and after holding the gallbladder, this needs to be withdrawn into the 10 mm port and removed together with it. This is the liver retractor. It's got a handle and a knob which is used to open the blades. It's got a shaft, and these are the blades or the retracting blades. Now these blades can be opened by rotating this knob, and again can be put to a closed position by rotating it in the other direction. And this is another side connection wherein you can attach either suction or irrigation. And this is mainly used by dissecting the gallbladder from the gallbladder bed, and this mechanism, this instrument is specially designed to stop the bleeding from the liver bed, and in contrast to a hook wherein the cutting part is more than the coagulating part, this part of the spatula helps in careful cauterization of the small bleeders which come out while dissecting the gallbladder from the liver bed. And this is the shaft. This is the attachment for cautery, and as you can see, few of the spatulas also have the suction and irrigation device, and this knob is used for switching between the suction and the irrigation device. Stone holding forceps. It's got a handle and a shaft and the jaws to hold the stone. The handle has a mechanism in which as soon as you open it, it springs back to the closed position, and careful application of this forceps can be used for holding stones which might be spilled inside the dural cavity.